Hello everyone. Let us now do another one numerical problem based on the Laplace equations. Here it is given the potential function with a constant a. Find this constant a so that Laplace equation is satisfied. Which means first we need to consider this potential function satisfies Laplace equation, and we are going to find what is the value of this constant a. And the second one is with the value of the constant a, we are going to find the electric field vector at this given point. So let us do it one by one. First, let us do the first subdivision. We have to find a so that the Laplace equation is satisfied. We know Laplace equation is del square b equals to 0. Now, if this del square b equals to 0, then we can find a. So let us first find del square b. This is in rectangular system, which is dou square v by dou x square plus dou square v by dou y square plus dou square v by dou z square. This has to be equated to 0 since this is satisfying the Laplace equation. And then we can find the value of a. So this potential function v has to be 2 times differentiated with respect to x, y, and z. So let us write one by one. Dou by dou x of x square y z plus a y cube z. Then dou by dou y of x square y z plus a y cube z. Then similarly, second order differentiation with respect to z of the same function, x square y z plus a y cube z. Now we have to perform differentiation with respect to x for this, differentiation with respect to y for this, and differentiation with respect to z for this. And we should check whether this is becoming, we already know that this is 0. We have to find the value of a. So the first order differentiation will give 2xyz plus 0 for this term, and here first order differentiation with respect to y for this term will give x square z plus 3ay square z. Then differentiation with respect to z of this term will give x square y plus a y cube. This is equal to 0. Next, we should do second time differentiation of this, which will give 2yz. Then here you will get first term 0, second term you will get 6ayz. Then differentiation of this with respect to z is 0, equals to 0. Now we can take this 2yz common. 1 plus 3a equals to 0. Now this variables y and z cannot be 0. Thereby only this is equal to 0. So 1 by 3a only can be equated to 0. From this you can find a is minus 1 by 3. So thereby substituting this, our potential function b will become x square yz minus 1 by 3 y cube z. So this is the potential function v. Now making use of this, we are asked to find in the second subdivision, you need to find electric field vector. So we will make use of this potential function v and find electric field vector in this case. Now we have got the value of a is minus 1 by 3, and thereby applying the value of a, we will get the potential function. Now we have to find the electric field intensity vector. So we need to know the formula relating electric field intensity and potential. That is, electric field intensity is negative gradient of potential. So we should write the formula for gradient in rectangular system, which is dou v by dou x ax cap, dou v by dou y ay cap, then dou v by dou z az cap. Now we should take this potential function v and differentiate with respect to x, with respect to y, and with respect to z in each of the directions to get the electric field intensity vector E. So first let us consider, take this v, differentiate with respect to x, that is going to give 2xyz ax cap. Then differentiation with respect to y of this function will give x square z minus 3y square z by 3 ay cap. Then differentiation with respect to z will be x square y minus y cubed by 3 az cap. So this is the electric field intensity vector in terms of variables. We should substitute the values of x, y, z at this corresponding point. So the point P with the coordinates 2, 1, minus 1, whereby x should be substituted as 2, y should be substituted as 1, and z should be substituted as minus 1 to get the E vector for this. You can substitute and get the expression. I'll wait for a while. Now, by substituting the values of x, y, z corresponding to the point P, you will be getting the vector E as 4ax cap plus 3ay cap minus 11 by 3 az cap. This is the vector E, and we should write the unit for vector E, which is foot per meter. So I hope you have understood this problem. Thank you for watching the video.